Good evening, everyone. So a lot of you today told me to give you some examples of how you evaluate fractional exponent with bigger number than the one we had before. So let me share my screen. Okay. I have a couple examples here that I would love you guys to work on with me. So if I do this one, these are small numbers, so very much if I put as a radical, cube root of the degree is 3 and 3 to the fourth power, which equal to 3 times 3 times 3 times 3, which is here the cube root. And because of the cube root, I take each 3, I'll take 1 out, and I left with 1 inside. Cube root 3 radical 3. But that's easy to write it, write the 3 4 times like this. But what if I have something like this? 3 to the 29, 11. So if I want to do the old-fashioned way, it's going to be degree is 11 of the root, 3 to the 29. Will I really write 29 times? No. So the easier way is I divide 29 by 11. Pay attention. So what I do after dividing 29 by 11, that will give me 2. 2 times 11 is 22. The remainder is 7. So this number here, always the exponent of the base outside the radical. The base is 3, so there will be 3, exponent is 2, outside the radical. And this number is the exponent of the base inside the radical, which is the remainder. The base is 3, and that will be 7 over here. And also, there is the 11th root. That will be the answer. Let's spice it up a little bit. How about something like this? All right, let me move my picture, make it a little small. Excuse me, Mikhail, thank you. So if I want to do this one, I will have first to divide 65 by 17. And if I use the calculator to divide 65 over 17, I'll get 3. 3 times 17 multiply give you 51. The remainder is what? Excellent. The remainder is 14. So this is exponent, and this is also an exponent. But what's different is this outside the radical, this inside the radical. So the answer is going to be the 2x outside the radical to the power what? To the power of 3. Exactly. This goes here, the power of 3. And then I put the radical and the 17th root of the same base to the power of 14. And that will be my answer. Let's spice it up a little bit. What I have here is I have different exponents. Let me put my picture up there. I have 7 to the first power. This 3 is over 1 and this over 1. So the first thing I'll do, I will actually multiply this by each power, by both. So this is going to be equal to 7. 12 times 1 is 12 over 5 times 1 is 5. When you multiply this times this, top times top, bottom times bottom, that's going to give you 36 over 5. All right, now I'm going to treat this one separate. I want to know what 12 over 5 is, and also 36 over 5 is. So if I do what I did before, 12 divided by 5, that give you 2 times 10, the remainder is 2. So this number is going to be 7 squared, such that this number goes here. times inside the radical, which is, what's inside the radical? 7 squared as well, but inside the radical. And remember, the root is 5. All right, so this part equal to this. All right, now, how about this? So, if I do 36 divided by 5, I'll get 7 times 5 is 35. Remainder is 1. That's an exponent. That's an exponent. So that will equal to m to the power 7. Then I put the radical. Remember, the degree is 5. This goes on the top here, 1. And this is over here. So the answer, m to the 7, fifth root m to the first. Now, am I done? No, Mikhail. What I do next is I'm going to take number outside the radical, which is this one and this one, and I'm going to put them together. That will be 7 squared, which you can simplify as 49, m to the 7. Then I'm going to put my radical and put number inside the radicals together, which is going to be this one and this one. So that's inside going to be also 7 squared, m to the first power. And don't forget the degree is 5. And that's it. Now let's spice it up again and do many of those. Excuse me, Mikhail, can you go up here? Sure. You see how nice I am? In this one here, I'll do the same thing. So I'm going to divide this over 1, over 1, over 1. The first step, you're going to multiply each one. Multiply. So it's going to be 3. 11 times 2 is 22 over 3. P, 11 times 4 is 44 over 3. And C, 11 times 2 is 22 over 3. Now I'm going to do each one individual. So I'm going to do each one individual. Do the long division like what we did before. All right, 22 over 3, that's going to give you 7. 21, the remainder is 1. I care more about this number, this number. So this is going to be 3 to the power of 7, radical 3 to the first power. How about this? 44 divided by 3. 44 divided by 3 is going to give me 14. 14, yes. 14 times 3, that is 42. So remainder is 2. I care about this. I get about this. That's going to be P to the 14 and radical P squared. Don't forget, Mikhail, the degree of the radical is always 3. Cube root. All right. Now, the last one, C. So 22 divided by 3 is 7. 21, the remainder is 1. I care about this. I care about this. That is C to the 7 and C inside to the first power. And again, degree is what? Is 3. Now what I'm going to do next, everything inside the radical, which I have 3 inside the radical, this, going to be still inside the radical. And the thing that outside the radical, 1, 2, 3, going to put them together outside the radical. So my final answer is going to be 3 to the power of 7, P to the power of 14, C to the power of 7, cube root, forget the degree, is extremely important, of 3, of 3 P squared and C. And this is going to be my final answer. So final answer is this over here. Now, if I have a negative exponent, like if this is negative, if it's negative, will be 1 over this answer here, but it's not negative. You notice something. Exponent here is 1, exponent is 2, exponent is 1. The exponents here on the top cannot be greater than the degree of the root.